All right, let's take a look at worksheet 4.8, compositions of functions. This is where we take the answer from one function and use it as the input of our second function. So on this one, we're given a couple functions, f of x equals 3 plus the square root of x plus 5, and g of x equals 2 plus the quantity of x minus 1 quantity squared. Find these values. So to find g of 4, I'm just plugging that one just straight into our equation. So I'm going to go 2 plus 4 minus 1 quantity squared. Well, 4 minus 1 we know is 3. 3 quantity squared is 9. 2 plus 9 is 11. So g of 4 is equal to 11. Now in part B, this is where it becomes very helpful. I'm trying to find f of g of 4. Well, g of 4 from my previous problem was 11. So I'm going to replace the g of 4 with what it equals, which was 11. So I'm really just now trying to find f of 11. So now I plug 11 into the f of x formula. 3 plus the square root of 11 plus 5. Well, 3 plus 11 plus 5 under the radical is 16. Square root of 16 is 4. 3 plus 4 makes 7. So f of 11 here at the end ends up being 7. Or f of g of 4 ends up being 7. Alright, same process with c and d. They kind of go hand in hand. I'm going to find f of negative 1. So f of negative 1 is equal to 3 plus the square root of negative 1 plus 5. Well, negative 1 plus 5 is 4. Square root of 4 is 2. 3 plus 2 is 5. So f of negative, almost wrote f inverse, my apologies. So f of 1 is equal to 5. So I'm going to now, in D, replace that f of negative 1 with 5. So really what I'm looking for is g of 5. So g of 5 is equal to 2 plus 5, which is x, minus 1 quantity squared. So g of 5 is equal to 2 plus 4 quantity squared. 4 quantity squared is 16. 2 plus 16 is 18. So g of 5 is 18. Alright, that takes care of number 1. Alright, number 2, these functions g of x are defined by these set of input and output values. So this is where we get to use the points to try to figure out our end result. So this becomes a lot of fun. I kind of like this one. So first of all, I need to figure out what f of 4 is. So I go along here. When x is 4, f of 4 is 1. So I'm going to replace the f of 4 with 1. So now I'm really just looking for g of 1. Well, g of 1 is equal to 2. So I got my answer. Same process for the next one. G of negative 2. So I look at the g of function. G of negative 2 is equal to 4. So now I replace the g of negative 2 with 4. So now I look at the f of 4 function. Well, 4 is actually equal to the 1. Because when x is 4, the f of x function equals 1. Alright, the last one. This is where we get to go back and forth a couple times. F of 3. So I go along f, and sure, 3 makes this 5. So I'm going to replace the f of 3 with 5. So I have f of g of 5 right now. Well, g of 5, when g is 5, or x is 5, g of 5 is also 5. I'm really looking for 5, because g of 5 equals 5. So I'm now looking for f of 5. Well, f of 5 is right here. It equals 0. That takes care of number 2. Number 3. Love this problem. Because it's talking about swimming. What else is new with Mr. Bartz? So, number 3 says here, graph A shows a swimmer's speed as a function of time. So as time is increasing, you can see their speed starts to level off. Graph B shows the swimmer's oxygen consumption as a function of speed. So as they're going faster and faster, of course, they're going to consume more and more oxygen. So question A says here, the swimmer's speed after 20 seconds of swimming. Well, what is a swimmer's speed after 20 seconds of swimming? So I go here, go up here, look at the swimmer's speed. The swimmer's speed is approximately 1.5 meters per second. Okay. So now B says the swimmer's oxygen consumption at a swimming speed of 1.5 meters per second. So I go along the second graph, 1.2, 1.4, 1.5, come up here, go straight across, and it looks like they're consuming about, I would say, 13 liters per minute of oxygen. So now, we want to find the swimmer's oxygen consumption after 40 seconds of swimming. So here's the composition. A and B took you so that you got the speed, and then you use the speed to get the oxygen consumption. Here you have to do both pieces. So let me switch to a good color here. So I first start with traveling 40 or going at 40 seconds. So if I go to 40 seconds here, go straight across, it looks like my speed is about 1.9 meters per second. So now if it's 1.9 meters per second, go straight up, go straight across, it looks like I am consuming about 15 liters per minute of oxygen consumption. All right, that takes care of the first page.